So we will be discussing different types of circuits biasing of your BGT amplifiers under RE model. So we have this first configuration, the common emitter configuration, fixed bias circuit. So this is our fixed bias circuit, a circuit without a resistor in your emitter side. So we have to change this one into your EC model. Then we have to put our current. So we have this one as IS, then followed by IB. This will be our IO, followed by IO prime, then IC. The voltage across this terminal is what you call your voltage base. And also we can get your impedance base. And this is your BI, where you have your impedance I and impedance IN. And this is our output impedance. So solving for your input impedance, first we have to get the impedance at the base, which is equals to beta RA. And solving for your impedance I, that is equivalent to your RB in parallel with your impedance at the base. And for your impedance IN, that is equals to your RS plus your impedance I, because your RS is in series with your impedance I. And for your output impedance, by setting BO or BS to 0, we have output impedance equals to RO in parallel with RC and in parallel with RL. For the voltage gain, that is equivalent to BO over BS, because your input voltage is BS. Or it is equivalent to BO over BI times BI over BS. Solving for your BO, it is a voltage across your RL. And the current that flow in your RL is IO, but the polarity of your IO is against the polarity of your BO. So therefore, that is equivalent to negative RL IO. Solving for your IO equation, that is opposite resistance, which is RC, all over RC plus RL times IO prime. And then, we have also to get the equation of your IO prime, which is equivalent to your opposite resistance, which is RO, over RO plus RL in parallel with RC times IC. Substituting this IO prime to your equation of IO, so therefore this is our equation of our IO. But IC is equals to beta IB. Then we have to substitute this IO to your BO. Therefore, we can rewrite your BO as negative RL in parallel with RC in parallel with RO beta IB. Then our beta input or voltage input is equals to beta RE times IB. So to get your BO over BI, so that is equals to negative RL in parallel with RC in parallel with RO all over RE. And we have also to get the equation of your BI, that is the resistance where your BI, which is equivalent to your impedance I, over impedance I plus RS times BS. So the ratio BI over BS is equivalent to impedance I all over impedance I plus RS, or impedance I plus RS, that is your impedance IN. So your voltage gain is now equivalent to negative RL in parallel with RC in parallel with RO all over RE times impedance I over impedance I plus RS. For your current gain, that is equivalent to IO over IS, or we can rewrite that one as IO over IB times IB over IS. So first, we have to get the equation of your IO, which is RC all over RC plus RL times IO prime. And the equation of your IO prime is equals to RO over RO plus RL in parallel with RC times IC. And since IC is equals to beta IB, so we have this equation for our IO. It is RC all over RC plus RL times RO all over RO plus RL in parallel with RC beta IB. Then we have to get the equation of your IB, which is equals to opposite resistance, which is RB, plus RB times your impedance at the base, which is beta RE, then times IS. So therefore, using the ratio IO over IB and IB over IS, so therefore, your current gain EIS is equals to RC all over RC plus RL times RO beta over RO plus RL in parallel with RC times RB over RB plus beta RE. Another method in solving for the current gain is using your voltage gain. So as we know that your IO can be derived from your BO, which is equals to negative RL times IO. So therefore IO is equals to negative BO over RL. And your IS can be found at your BS. It is impedance IN times IS. So IS equals to BS over impedance IN. So EIS, it is IO is equivalent to negative B over RL, and IS is equivalent to BS over impedance IN. To simplify this equation, so we have negative BO over RL times impedance IN over BS, or that is equivalent to negative BO over BS times impedance IN over RL. So therefore, your current gain is equals to negative EBS times impedance IN over RL. So that is all for the fixed bias circuit.